there, let's talk about trigonometric functions and mainly how to solve any type of triangle within this interval using reference angles and how to apply periodic trigonometric functions into real-world problems, and lastly, trigonometric identities. Let's get started. First, let's solve these two problems. Sine of x equals square root of 3 divided by 2. First of all, we have to draw out a triangle, determine which quadrant it's in, and square root of 3 divided by 2 is in the first quadrant because it's positive and it's less than 90 degrees. So let's draw it. We need to know what sine looks like. And if the angle is right here, let's call this theta, and sine is always opposite hypotenuse. So it's this angle and that side and that side. And if it's going to be square root of 3, let's put that right here, and 2 right there. And now we know what it looks like. We still need to solve for the angle. So what we need to do is determine, based on our knowledge of 30, 60, 90 triangles, what is the angle right here. Well, if this is 1, square root of 3, and 2, we know that this side is 30, 60, and 90. So we know that theta equals 60. And it's in the positive quadrant. And now let's move on to the next one. Sine of x equals 120. We know that that's in the second quadrant, so let's draw a triangle like this with the angle theta right there. We need to use a reference angle to solve, so a reference angle would be 180 minus 120, which is 60. So, since we know that the reference angle is 60, that means we can solve for the angle by determining which side is going to have a 60 degrees. 60, 90, and 30. And for 60, this side is square root of 3, 1, and 2, and negative 1. So we can just duplicate that right here. And we do get that sine would be square root of 3 over 2. Now the reason why I did this is so you can see that we can write this in radians and degrees and we can still get the same result, just flipped. Alright, let's try this with some cosines now. So let's solve for these two. Cosine of x equals negative square root of 3 over 2. For here, it's negative, which means we have two options between the quadrants. We have 1 is not an option because it's positive. 2 it is, so check. 3 it is. And 4 is positive, so no. So we're looking at these two right here for negative cosines. So we would write, let's start at quadrant 2. We use that. Theta and negative square root of 3 would be right here because we know it's cosine, and 1. Now if we look back to our triangle again, we know that side 1 is equal to 30 degrees. But for quadrant 2, that would be 150 degrees. For quadrant 3, it would be a triangle such as this with theta here. Same thing, let's do negative square root of 3 and 2, and this side would be negative 1. And we would get equals negative 30. Also known as 210 or negative 150. Alright, now let's do this side, and it's pretty much the same, but we're looking at it degrees instead. So let's go ahead and solve that. if we know the angle is already 150, we're looking at a reference angle of 30. Let's write that down. So if we're looking at 30, we know this side is 1, and if we know the cosine is 30, we can say 1 negative square root of 3 and 2, and we still get the same thing. And the same thing for the upside down. If we know it's 30, then we can say here negative 1, negative square root of 3 and 2 equals 210. Now let's go to tangents. So here's our final example. Tan of 1/2 equals x. We draw any positive triangle, so let's do quadrant 1. And we have 1 and 2. So this is kind of weird, right? Because this isn't your standard 40, 60, 90 or 45, 45, 90. So actually, we'd have to use a calculator for this one to find what is the angle. So we would just do into your calculator tan insert parentheses 1/2 equals, and that would be around 0.78 degrees. So now that we know that, let's move on to the next one. Tan x equals 120. That's in the second quadrant that we know, so that'd be right here. And we know it's negative. It has to be negative because tangent is always negative in quadrant 2. Let's say 120, we would have to find the reference angle, which is 60. 120 subtracted by 180 is 60. So 60 right here. And the opposite side would be square root of 3. This would be negative 1, and that would be 2. So that would be negative square root of 3. Alright, we've got that covered. Now let's move on. For trigonometric functions, there are so many applications you can use them for. You can use them for Ferris wheels, temperature changes in a day, and outside temperatures over a day or months or years, or Ferris wheels, population growths, and so many other applications. And this is the basics, graphing sine graphs or cosines, or even tangent or cotangent graphs, or secant, cosecants, and there's so many ways to apply this into everyday life. Now for trigonometric identities, these are the key ones you must memorize. It's kind of easy to get the hang of it once you realize that there's a pattern. Sine and cosecant are actually inverses, that's why they're inverses. Same thing with cosine and secant and tangent and cotangent. And for Pythagorean identities, it's just building up a triangle and seeing which ones add up to the hypotenuse here, or 1. And sine would be this side and that side, and cosine is this side and that side. So when you negate those two, you would get just this side left over, which is always 30. If that makes it a little easier to remember. So let's get started with some examples. So here on the upper left, you have the identities and all the formulas you're going to use, right? So let's start off with the first problem. Make it kind of simple. Tan x sine x plus cosine x equals secant x. Alright, let's draw a triangle. Let's say we have this triangle right here. And let's label sine, cosine, and tangent from this point. It's called theta. Sine is opposite with hypotenuse. That's sine. Cosine is adjacent and hypotenuse. And tangent is opposite with adjacent. Now that we have that covered, we have to kind of know the identities of the trigonometric functions. And tangent can also be written as sine of x over cosine of x. Why is that? It's because if we take sine over x, which is hypotenuse over opposite over hypotenuse, opposite over hypotenuse, over cosine, which is adjacent over hypotenuse. By multiplying that, we actually get opposite over adjacent, which is tangent. And that's kind of how we know it works out at the end. So we have tangent covered, so sine x over cosine x times sine x plus cosine x equals, what's the next step here? Well, we can actually say that we want to multiply these two signs together and get sine x over cosine x plus cosine x. And in order to get a common denominator, we can just rewrite this cosine as cosine squared x over cosine x. And that's the same thing, except we're just making the denominators the same. Now that they have the same denominator, we can combine the two and say sine 2x plus cosine squared x over cosine x. Now here's where some of the Pythagorean identities come into hand. Sine 2x plus cosine squared x, it's actually equal to 1. And because we know that, our final answer will be 1 over cosine x. Alright, so the main concepts for trigonometric functions is to know the inverses. Everything right here is very important, and applying them into real-world applications. Thank you for watching. This has been provided to you by SATFreePractice.com.